Again, this is training obviously for Victor Valley College in regards to the heating hot water system for comfort, obviously for maintaining space temperature. So what we have to, as a complete system to make that happen, is we have 2 secondary pumps, and then we have 2 boilers. These are Raypack boilers. The Raypack boilers themselves have their own primary pump. I don't know if you're familiar with primary secondary pumping. Are you guys familiar with primary and secondary pumping? The gist of it is you have a primary pump. It's no different than we have on cooling systems, on chillers. We have a primary pump that feeds water to the boiler. So when that pump discharges, it goes out. The line goes across, which is intercepting the second boiler. There's check valves on these pumps. You don't see them. Then the water is going in, and it's going into this tank. Big open tank. Then out of the tank, the pumps are drawing the water. It goes back to the header. It goes back into the primary pump, and then feeds the boiler. So you have 2 separate loops that are just feeding the tank. So all these pumps do is maintain the internal loop here. The secondary pump, which are the 2 pumps on my right, be one. Basically, they're sequenced. Obviously, one starts, and if it goes to above 95% for a duration of like 5 minutes, then it starts the lag pump. Obviously, the secondary pumps are what draw the hottest water off of the tank that's being supplied by the 2 boilers. Water comes across. 140-degree water is the highest we have. It's 140 or 120 with a reset schedule. So the water goes into the inlet of the pump. It discharges. It comes across. And then it feeds the header. Okay, this set of lines here is going over to air handler 2. The lines that continue on are air handler 1. And everything above over here on this side is actually going down below ceiling line and going to all the VAV boxes. Okay? So, how do the secondary pumps work? There's a pressure transmitter located on the first floor on the east side that monitors between supply and return. So, no different than a VAV system, when the valves close back, being an air valve, this is the same thing for a hot water valve. As the hot water valves start to close, then the increase in differential pressure goes up. There's a set point right now at 12 psid. Once there's an increase in pressure, then it actually sends a signal via the BMS over to the drive that's serving the pump, and it slows the pump down on an inverter, no different than the air handler. It's just an ABB drive versus a Danfoss drive. Okay? If you were in a situation where you had to run it in hand, as far as the secondary pumps, you can do so, and I'll show you an electronic bypass how to turn that one in hand. It's different than this because these have basically a rotary switch, where the other ones actually have a push button electronic bypass section. Okay? On this particular system, you have a PRV station. Obviously, you have a backflow preventer because this is industrial water, not domestic water, right? So you have to have a backflow preventer. You have to be certified, right? So you have to have the I don't have the frequency, but you have annually to get these certified. So then you have incoming gauge coming in. You have your PRV, your PRV valve, which is set for 25 pounds. The expansion tank is a bladder style expansion tank. There's an air fitting on the top to check the pressure. To check the pressure on a bladder style tank, you basically want to have the boiler system off, because you have to drain the entire bladder to make sure the pressure is accurate. Okay? What happens is, I don't know if you're familiar with the old atmospheric tanks. They would sit below the boiler line, and then you have like a 12-pound makeup and a 30-pound relief. The reason being is you could drain the whole tank, and it would be atmospheric pressure of 14.7. The makeup would be 12. You open it up and see water like halfway in the tank. Well, these are bladder style tanks. There's a big balloon inside there. Okay? So on the edge of this flange is basically a rubber boot. It's flanged down, and here's a fitting, and there's basically the rubber fitting basically goes into the air bladder. So there's a big balloon on the inside. It basically expands and contracts based on water temperature, and the water comes in the bottom. So to check that, you would close But obviously close the line that's going into the heating hot water system. Right now the reason why it won't close is because I took the handle and put it upside down backwards. Because this is the most critical thing that's on this system, even though it doesn't seem like it does much. The reality is that maintains the expansion and contraction. If it wasn't there, you'd be blowing the relief off. You're basically trying to maintain the system pressure at one constant value. So take the handle off, close the valve. You can drain it out of the tank, and then at that point you can check the pressure. And once that's done, then you could obviously open up the makeup water, fill the tank back up, and then open up the connection going into the system. But this has to remain open. Okay. We have a pot feeder. Right now the valves to the pot feeder are closed. If you want to obviously put any kind of chemical like inhibitor, you have to maintain the integrity of the system. So you guys familiar how to open and close the pot feeder? So if it's a pot feeder and you want to put chemical in the system, the valves will be closed. Then ultimately you have a drain out the bottom. So if you open the drain out the bottom, if those valves are closed, even the valves here, you can close these as well. You just drain the tank versus those lines. Once the water level, stop the drain, cap can come off. Right, the residual water goes out, you drain it down to the level you need to drain it to, and then you would actually obviously put chemical in it, right? Inhibitor. You want to make sure inhibitor level's out, whatever the recommendation for the chemical you guys have for your supplier. It was usually about 1,300, between 8 and 1,300. So once you were to put chemical in, let's say for instance, it's only half full. You don't want to put that air in the system. We do have an automatic air vent for air. So if these valves were open, not getting anybody hot water today, then I could physically open up the bottom valve and I could start to fill it. Okay? You don't want to obviously have chemical in here. You don't want to get chemical on you, right? But you can watch the water level come up. Obviously the drain's closed.
Does it have chemical in it now?
There's an inhibitor in it now, yeah. Yes, there is. Well, just go slow. Obviously you don't have anything on you, so it's... Again, don't take the cap off when it's pressurized. So we're getting to the top now. Make sure you close the valve the right way versus the wrong way. Okay, so now we're near the top. As you can see, you have some suds up here. You obviously want to put the handle cap back on, close it, and then you want to open up your valve slowly to make sure you don't have any leaks. Once you have any leaks, you can open up the bottom and top valve, leave the bypass closed, and now you're basically circulating through the tank to get rid of whatever inhibitor that you put inside the tank. Now, once you're done and you let it run for, let's say, an hour, and the inhibitor now is in the system, please come back and close these off because this is acting like a coil. So what's going to happen, it's going to, again, if it's open, the delta P at the transmitter goes down, it increases the pump speed so it can maintain its set point. So basically you're running hot water back through the tank, which inherently is affecting the primary loop. So you want to make sure you keep this closed after you put inhibitor in, let's say after you run it for an hour. Okay? There is a relief in the back, so if the pressure in the system gets too high, if the PRV station goes bad, it would actually dump water in the drain, and obviously you have to address the PRV valve if it fails.